Welcome to the Deep Dive, the show where we really try to cut through the noise and get straight to what matters. Today, we're plunging into, well, a pretty complex world, the construction industry. Huge projects, grand visions, right? But let's be honest, it's also often tangled up in some incredible complexities. We've all heard the stories, maybe even lived them. Projects hit with frustrating delays, costs just spiraling out of control, inefficiencies that almost seem baked into the system, like it's just part of the game. But what if there was a different way, a genuinely transformative approach, something that could make building, more predictable, more efficient, and maybe even build a stronger team spirit along the way? Imagine a construction site where everyone, really everyone, from the architect down to the skilled tradesperson, is pulling in the same direction. A place where waste is like systematically hunted down and eliminated, and where promises, commitments are actually kept. It sounds almost revolutionary, doesn't it? And yet that's exactly what we're going to explore today.
It really is. We're diving deep into this powerful philosophy called lean construction. And look, this isn't just some passing trend or, another toolkit to stick on your belt. It's a fundamental shift, a different way of thinking about how projects are conceived, planned, and then actually delivered. It draws inspiration from some incredibly efficient manufacturing processes, think Toyota, but adapted for the unique world of building. It's about rethinking the entire life cycle, seeing it as an integrated system focused on delivering maximum value.
Okay, so our mission for this deep dive is pretty clear, and it's tailored just for you listening. We're going to unpack the origins of lean. Where did it even come from? Trace that journey from the factory floor to the, let's face it, often chaotic construction site. We'll dig into its key adaptations for construction, introducing you to systems that are, frankly, game changers. Things like the last planner system, target value design. And to make it real, we'll use some imagined voices, snippets from people in the field, illustrating how this stuff actually works, the successes, the impact on cutting waste, boosting reliability, and really improving that team culture.
Yeah, our goal is to give you a solid understanding pretty quickly, actually, hopefully sparking some of those aha moments, giving you different perspectives without just drowning you in information.
Mm.
Because as you know, the construction industry, it's always changing. There's emerging technology, new approaches, rapid market changes all the time. Understanding lean gives you a framework, a really solid one, to not just react, but to be, proactive, innovative, and nimble in actually delivering those project outcomes. So, yeah, let's get started. IHA, the genesis of lean, from Toyota to the construction site.
Okay, let's unpack this then. Where did this whole philosophy of lean actually start, and why is it so relevant for construction? Because, on the surface, building a skyscraper feels worlds apart from making cars on an assembly line, right?
That's a great question, and it's fundamental. To really get lean construction, you absolutely have to go back to its roots, back to manufacturing, and specifically the incredible work done at Toyota in Japan, the Toyota production system. After World War II, Toyota was facing huge challenges, limited resources, a small home market, trying to compete with these massive American car companies. They just couldn't afford the waste that came with traditional mass production. So their solution, which was pretty ingenious, was to build a system around constantly identifying and eliminating waste. They call it muda in Japanese. The whole goal was creating maximum value for the customer. And it wasn't just about cutting costs. That's a common misunderstanding. It was this relentless, system-wide focus on efficiency, embedding quality at every single step, and creating a culture where literally every employee, from the shop floor up, felt empowered to spot problems and suggest improvements. They identified things like waiting, making too much stuff, defects, unnecessary movement, holding too much inventory, overprocessing things, even unused human talent, all as forms of waste. Things that just drained resources and didn't add any real value.
Right.
Their real breakthrough was seeing these weren't just small annoyances. They were the root cause of unreliability and higher costs.
Okay, so that makes sense for a highly repeatable process like building cars, where you can standardize every little thing. But how did those ideas jump over to something as messy and, well, unique as constructing a building? Every building project is almost like a one-off prototype, right? Built on a specific site under unique conditions, often with custom designs. It doesn't feel like an obvious fit, kind of like that square peg, round hole thing.
It's a really astute point, and it actually highlights how adaptable lean principles are. You're right, construction isn't an identical assembly line, but it shares so many of the same underlying challenges. Managing variability, tasks depending on each other, quality control issues, and ultimately the need to deliver value efficiently. The leap wasn't, immediate or direct in some ways, But Lean's influence on construction is actually part of a much bigger evolution happening in project management overall. In fact, things like Lean, Agile, and design thinking principles were specifically called out as major research inputs that help shape the latest version of the standard for project management, the PMBOK guide.
Oh, interesting. So it's recognized at that level.
Absolutely. Which tells you this isn't just some niche construction thing. It's now seen as fundamental to how we think about managing projects effectively across many industries. And this really reflects a bigger shift across the whole industry. The PMBO guide itself, it used to be very process-based.
Right, the ITTOs, yeah.
Yeah.
Inputs, tools, techniques.
Exactly. Very prescriptive. Inputs, tools, techniques, outputs for everything. But now it's moved to being principle-based.
So more flexible, focusing on the why, not just the how.
Way more flexible, exactly. The focus now is squarely on delivering the desired project outcomes. What the client or end user actually needs and values. It doesn't matter quite as much how you get there, which specific development approach the team uses, agile, waterfall, hybrid, whatever. It's about the result. So even though construction projects are unique prototypes, those core lean principles focusing on flow, maximizing value, eliminating waste, they're absolutely applicable.
Okay, so this isn't just some trendy idea that a few forward-thinking companies are trying out. It's actually woven into the fabric of modern project management, recognized by major global standards. That definitely gives it more weight than just being another buzzword.
Totally. It represents a fundamental shift in thinking. And one of the most powerful ways these lean principles have been specifically adapted for the construction environment is through something called the Last Planner System, or LPS. This is really a cornerstone of lean construction. It's designed not just to make things go faster, but crucially, to improve the reliability of the workflow and build genuine commitment among the teams doing the work. It's about making sure that what we plan to happen actually happens week in, week out. 2, adapting lean. The Last Planner System, LPS, in action. Okay, so the core idea behind the Last Planner System, LPS, it's simple, but actually quite profound. It's all about empowering the last planners.
Last planners, who are they exactly?
They're the people closest to the actual work being done on site. Think foremen, team leads, trade superintendents, the ones directing the crews, dealing with the day-to-day realities and, the inevitable curveballs. By deeply involving them in the planning process, making sure they have a real voice, you dramatically reduce the variability in the workflow. Things become much more predictable. And this lines up perfectly with what the PMBO guide talks about, needing clear direction regarding project requirements, outcomes, and expectations, and also that greater need for ongoing feedback, especially in adaptive environments, to keep things stable and refined. It's about letting the people who do the work be the main architects of the detailed plan for that work.
Right. Okay. Here's where it gets really interesting, especially for anyone who's actually been on a busy construction site. How do these collaborative planning sessions actually work in practice? I mean, I can picture it just dissolving into chaos, right? You've got all these different trades, different companies, everyone with their own priorities, trying to plan together. How do you keep that productive and not just a big argument?
It sounds like it could be chaotic, but actually, the system's strength is that it structures that collaboration. It prevents the chaos. LPS isn't just getting everyone in a room, it's a defined process. It moves way beyond that traditional top-down scheduling where, a project manager creates a master schedule in isolation and just hands it down. Forget that. Instead, LPS involves truly working collaboratively with stakeholders. That means bringing everyone together to introduce the project, elicit their requirements, manage expectations, resolve issues, negotiate, prioritize, problem solve, and make decisions together.
So what does that look like? A big meeting every week?
Well, there are key components. First is look-ahead planning. This is critical. The construction manager, the CM, usually leads this. They set up procedures for involving the on-site contractors in the development and updating of project schedules. This isn't just a quick chat. It's a structured session, typically looking maybe 3 to 6 weeks into the future. Picture maybe a big whiteboard or maybe a digital tool now with the foremen and superintendents from all the key trades, mechanical, electrical, plumbing, framing, concrete, everyone who needs to coordinate. Their goal isn't just to look at dates. It's to proactively identify anything that could stop work from happening as planned. Any potential roadblocks or constraints is a crucial material delivery looking iffy. Has a design drawing not been finalized or approved yet? Is the crew before them running behind schedule?
So finding the problems before they happen.
Exactly. By flagging these constraints early, the whole team then works together to remove them. They figure out who needs to do what by when to clear the path. The aim is to make sure that when it's time for a specific task to start, The site is ready, the materials are there, the info is clear, the work is genuinely ready to go.
Okay, that makes sense. So that's looking ahead. What else?
Then, building on that, you have the weekly work planning. This usually happens toward the end of the previous week, say a Friday afternoon. And this is where the real commitment happens. In this meeting, the last planners, those foremen and leads, make concrete public commitments about what their crews can and will achieve in the upcoming week, maybe the next 5 to 10 working days. They're not just assigned tasks. They are stating, yes, given that the constraints are cleared, we commit to completing these specific tasks this week. This process ensures cooperation and obtains commitment from each contractor. It builds incredible trust and accountability because everyone heard the commitment, everyone had input, and everyone is relying on each other to follow through.
Okay, I can see how that would change the dynamic. It's not just being told what to do, it's actively promising what you will do.
Precisely. Let's try and imagine hearing from someone on the ground, say Maria, a framing contractor, who's seen the shift. Imagine contractor voice. Before we started with Lean and LPS, it felt like we were constantly fighting the schedule, always reacting. We'd get this big master plan from the GC, full of dates, right? But half the time, you'd show up ready to go, and the materials wouldn't be there. Or the concrete slab wasn't cured properly. Or, the electricians were still running conduit right where we needed to frame. We'd have our whole crew there, tools ready, costing money, and we couldn't even start. It was incredibly frustrating, so much wasted time and effort. Imagine contractor voice. Now, it's like night and day, these weekly work planning sessions. We're not just getting told the schedule anymore, we're part of building it. We actively look ahead, identify those roadblocks as the lumber delivery confirmed. Is the floor clear? And we commit, out loud, in front of the other trades, to what we can realistically get done next week. So when we say we'll frame those walls on Tuesday and Wednesday, we know look-ahead planning has cleared the way.
The site's ready, the materials are staged, the guys before us are finished. We're not just taking orders, we're making reliable promises. And the communication, it's constant. We talk directly to the MEP guys, the concrete crew. What do you need from us? What do we need from you? It just creates this much smoother, more predictable flow. And honestly, a lot less yelling and finger pointing.
Yeah, I can really hear the difference that makes. Less frustration, more predictability.
Exactly. And that systematic involvement, that collaboration, it really boosts what the PMBOK guide calls scope stability and ease of change. Because you're catching potential issues way earlier when they're easier and cheaper to fix, and you're doing it collaboratively. The plan isn't some static document gathering dust. It's alive, constantly being refined by the people actually executing the work.
Okay, so with this level of tight collaborative planning, really understanding what's needed when, and removing those roadblocks, this must have a huge knock-on effect on getting materials to the site, right? Because that's often a massive headache, either too much stuff cluttering the place up or not enough when you desperately need it.
Oh, absolutely. It's a direct and incredibly valuable consequence. This accurate, collaborative planning, the kind that comes from LPS, is what makes just-in-time JIT material delivery actually possible in construction. This is a fundamental shift away from the traditional approach, where you often order materials way in advance, just in case, building up big stockpiles on site, which leads to so much waste.
Waste in what sense? Just taking up space.
Well, yes, space is a huge one, especially on tight urban sites. But think about it, over-ordering materials you don't end up needing, materials getting damaged by weather because they're sitting outside for weeks, things getting lost or even stolen, the costs of handling and rehandling materials multiple times, it all adds up. JIT, enabled by reliable planning, cuts way down on all of that. It tackles the waste associated with premature delivery, excessive storage, potential damage, theft.
Yeah.
Think about having, a huge delivery of expensive drywall arrive weeks before the framing is even done. It's sitting there, getting in the way, maybe getting damp.
Right, asking for trouble.
Exactly. From a green building perspective, this directly helps with reducing construction and demolition waste and supports having a proper construction waste management plan. It's not just about being tidy. It's about resource efficiency. It also helps optimize equipment resources. Cranes aren't waiting for trucks, and materials aren't sitting around waiting for a crane to be free. It cuts storage costs and reduces losses from things like odd lot sizes. Having to buy a whole pallet of something special when you only need a few pieces, and the rest just becomes extensive scrap.
So practically, how does JIT work then? Does the steel truck just roll up exactly when the crane is ready?
Ideally, yes, or very close to it. It means materials like those big steel joists or maybe fragile precast concrete panels arrive on site precisely when they're scheduled for installation, maybe the day before or even the morning of. This avoids all those risks of improper storage, like moisture penetration, mold, and mildew, which can wreck materials and even cause health issues later. For some materials, like paints or sealants, it even allows for necessary off-gassing of volatile compounds just before they're installed, rather than having them sit around potentially contaminating the site or other stored goods.
Yeah.
The whole supply chain just becomes leaner, more responsive, much less wasteful, both financially and environmentally.
Okay, that's a huge benefit flowing directly from better planning. Now, you mentioned another core lean principle earlier, one that tackles maybe the biggest elephant in the room for many construction projects: cost overruns, target value design, right?
Oh,
TVD.
exactly. Target value design, TVD. And this one really flips the traditional design process on its head. Think about the usual way. Architects and engineers design something, often aiming for a specific vision or function, and then only later does it get properly costed out by estimators or contractors. Now, what often happens?
Sticker shock. The cost comes back way higher than the owner expected or budgeted for.
Precisely, which then kicks off those painful rounds of value engineering, which often feels more like cost cutting. Trying to shave dollars off, sometimes by compromising key features or quality, just to get back down to the budget. It's reactive and often adversarial.
Yeah, nobody enjoys that process.
Yeah.
3, value-driven design, target value design, TVD.
Right. So 2DD takes a completely different approach. The core idea is, instead of designing first and then costing, you design to a specific pre-agreed target cost. And this target cost isn't just plucked out of thin air. It's meticulously developed right at the very beginning of the project, collaboratively with the owner, based on their budget constraints, and crucially, the value they want to get from the project. What's really important to them? TVD ensures that financial feasibility and stakeholder value are baked into the design from day one. It's not an afterthought. This lines up perfectly with the PMBO Guide's principles, like creating value for stakeholders and making sure project requirements, outcomes, and expectations are aligned with the financial and performance goals. And importantly, it encourages taking that longer life cycle view of value, not just the upfront construction cost, but the total cost of owning and operating the building over its lifetime.
Okay, that sounds incredibly powerful. A way to avoid those budget blowouts and make sure the owner actually gets what they value most. But how do you actually integrate that kind of strict cost control so early in the design phase? Isn't design supposed to be creative, exploratory? Doesn't designing to a cost stifle that innovation?
That's a common concern. But actually, proponents argue it does the opposite. It channels creativity within realistic constraints. It's not about saying no to ideas, but about understanding the cost implications as ideas are developed. It relies heavily on iterative and highly collaborative cost analysis. Right from the project's inception, maybe even before formal design starts, the construction manager, CM, or a cost consultant, develops an estimate of the cost of construction. But this isn't a one-time thing. The CM continuously reviews the budget for comprehensiveness, compatibility with any established cost limitations, and attainability as the design evolves. If a design choice starts pushing the cost beyond the target, the CM immediately reviews the findings with the owner and the design professional. They work together to make necessary design, program, schedule, and/or budget adjustments to conform to owner requirements. It's a constant, transparent feedback loop. Okay, this cool feature adds X amount. Is that value worth the cost, or can we achieve a similar value differently?
So it's about informed decisions, not just reactive cuts.
Exactly. And TVD absolutely just demands extensive collaboration right from the start. You bring the key players together, early architects, engineers, a general contractor, maybe even key subcontractors or suppliers. Often, they'll work together in what are called big room sessions or even co-locate. This early collaboration lets the CM prepare cost estimates for design alternatives in real time. They can run life cycle cost studies, energy studies, and preliminary cash flows to compare different options. So the team makes decisions based not just on the initial price tag or aesthetics, but on long-term value, operational efficiency, energy performance, maintainability, the whole picture. It shifts the conversation from just how much does it cost to build to what's the best overall value we can deliver within this budget.
Okay, so it's not just designing something cool, it's designing something smart and achievable from the get-go. And I imagine technology must play a huge role in making that real-time cost feedback possible. You mentioned BIM earlier. Building information modeling. How does that fit into TVD, especially those higher dimensions like 5D?
Oh, absolutely. BIM, particularly 5D BIM, is a massive enabler, maybe even essential for effective target value design. It's a real game changer.
So 5D, that's 3D plus time, 4D plus.
It's cost. That's the fifth dimension. Think of it this way. In a sophisticated 5D BIM model, Every element in the BIM model can be attributed to what it will actually represent in terms of resources and respective costs. So when an architect models a wall, it's not just lines on a screen. It's a data-rich object. It knows it's made of, say, metal studs, insulation, 2 layers of drywall, paint, and it has the quantities, the material costs, the estimated labor hours, even maybe the installation equipment associated with it, all linked directly to that 3D geometry.
Wow. Okay. So the model knows how much it costs.
Pretty much, yeah. And the impact is huge. It allows for parametric and dynamic quantity takeoff for bills of materials, which is a fancy way of saying the computer can instantly and automatically calculate how much of everything you need, every linear foot of pipe, every cubic yard of concrete, every light fixture, just based on the 3D model. This results in a more accurate estimate, obviously, but it also means less time spent by the estimators on the quantity takeoff and more time spent on performing cost estimate analysis. Instead of tedious manual counting, the estimators can use their expertise for strategic thinking, analyzing cost drivers, comparing alternatives, assessing risk, finding value opportunities.
So designers get instant feedback.
Exactly. They can make a change, maybe swap out one type of window for another, and see the cost impact almost immediately. It facilitates that rapid iteration, exploring options, and making informed trade-offs to stay within the target value and target cost. It keeps the design tethered to reality, ensuring value is designed in, not painfully engineered out later.
Okay, let's try another imagined voice. Maybe from an owner's perspective, someone who used TVD on a project with tough goals. Imagined owner voice. Our board had set an incredibly ambitious goal. Build a new research facility, make it highly sustainable, aiming for net zero energy, but within a budget that was, well, extremely tight. Honestly, we were worried. The typical green premium narrative had us expecting major cost battles down the line. We figured we'd design our dream green building, the bids would come in way over, and then we'd have to start stripping out all the important sustainable features just to make the numbers work. It felt inevitable using the old approach, imagined owner voice. But our project team proposed target value design. We bought the architects, engineers, and our chosen general contractor together right from day one, literally sharing office space for key design phases. We established that net zero goal and the budget as non-negotiable targets. Then, using 5D BIM extensively, they explored options. We could see, in real-time meetings, the cost implications of different insulation levels, window types, like comparing standard double glazing versus high-performance, spectrally selective units, or evaluating advanced geothermal HVAC systems versus more conventional ones. We ran detailed life cycle cost studies on everything. Sure, some better performing systems had higher upfront costs, but the model clearly showed the projected energy savings over the building's projected 50-year life made them the smarter financial choice in the long run, contributing to a lower total cost of ownership. Because we had precise 5D cost management capabilities integrated from the start, we designed a building that hit our sustainability targets and stayed within budget. We didn't have to value engineer our green dreams away. They were integral from day one. It resulted in a facility that's healthy, resource efficient, and ecologically based and financially sound. That's a fantastic example. Designing smarter, linking value and budget right from the very start, not treating them as separate battles, it really feels like it shifts the whole mindset from being purely cost-driven to being truly value-driven. Okay, so we've talked about these really powerful systems, the last planner system for workflow reliability, target value design for hitting budget and value targets, and how tech like BIM enables them. But beyond these specific tools or processes, what are the bigger picture benefits, the sort of overarching, holistic impacts of adopting a lean mindset on a project? How does it really change things from start to finish and maybe even beyond? Because it feels like it's adding up to more than just the sum of its parts.
Oh, it absolutely is. It creates this incredible ripple effect that touches literally every aspect of a project. These lean practices, they're not just isolated techniques you apply here or there. They weave together to create this interconnected ecosystem where projects just become fundamentally more efficient, more predictable, and honestly, even more collaborative and maybe even enjoyable for the teams involved. It's really about designing a better way of working together. 4. The ripple effect. Waste reduction, reliability, and culture.
You mentioned earlier that powerful idea from nature, no waste in nature, how ecosystems are incredibly efficient. How does lean translate that core idea of eliminating waste into the often, let's face it, messy reality of building things? Where does it find the waste?
That analogy to nature is really spot on. Because lean, fundamentally, is about reducing waste. It's about systematically, relentlessly identifying and eliminating anything that doesn't add value for the customer or the project. And the key is, lean looks for waste in places people often overlook. So, yes, there's the obvious material waste. We talked about JIT delivery, how precise planning minimizes construction and demolition waste. Think about those overflowing dumpsters on traditional sites.
Oh,
Lean aims to shrink what goes in them dramatically. It cuts losses from ordering too much, from damage during storage, from those odd lot sizes, and it slashes storage costs and the risks associated with having materials just sitting around. That's direct financial saving and a big environmental win.
Okay, materials make sense. What else?
Time waste. This is huge in construction. Lean tackles this head-on with the last planner system, that collaborative planning, removing constraints proactively. It directly reduces schedule slippages. It helps prevent delays, especially those common ones caused by design errors or changes that pop up mid-construction. And using 4D BIM, linking the schedule to the 3D model, lets you visualize the sequence, spot potential conflicts, see where crews or equipment might be idle, and fix it before it happens on site.
Rework must be another big one. Fixing mistakes.
Absolutely. Rework waste. This is where BIM's clash detection capability is just invaluable. The classic example. The HVAC design shows a huge duct running right where the structural design has a main support beam. In the old days, you might only find that when the duct installers show up on site. Cue expensive delays, finger pointing, and costly rework, maybe cutting beams, rerouting ducts. BIM catches those clashes, those interferences between different systems, digitally before a single worker steps on site. That, combined with thorough constructability reviews early on, prevents so much wasted effort and cost-fixing problems that should never have happened.
Are there other, maybe less obvious types of waste targets?
Definitely. Think about energy and water waste, not just during construction, but in the finished building. Target value design, because it focuses on life cycle cost studies and energy studies right from the design phase, naturally drives teams towards creating high-performance buildings. Designs that inherently minimize heating and cooling loads, with better insulation and smarter orientation, that maximize daylighting to cut electricity use, that significantly reduce water consumption with efficient fixtures or rainwater harvesting. It builds sustainability and long-term efficiency in it as a core value, not just a nice-to-have add-on. And finally, there's information and effort waste. Better coordination, clearer communication, processes like LPS, they drastically cut down on things like endless requests for information, RFIs, because the information is clear and shared more effectively up front. We talked about estimators spending less time on quantity takeoff and more time on cost estimate analysis. That's about freeing up valuable human brainpower from tedious, non-value-adding tasks to focus on strategic thinking, problem-solving, innovation, things that do add value.
Okay, eliminating all that waste time, materials, rework, effort must surely lead to more reliable outcomes because, let's be real, in construction, hitting the schedule and budget often feels like winning the lottery rather than the expected result. How does Lean instill that predictability?
That's one of its most significant impacts, absolutely. Lean practices are fundamentally about building a culture of predictability and confidence. So, schedule reliability gets a massive boost from the last planner system. That whole process of making commitments, tracking percent plan complete, PPC, learning from deviations, it trains teams to make and keep reliable promises. The percentage of planned work completed goes up. Deviations from the schedule go down. Visual tools, maybe a linear schedule, showing progress against time and location, help everyone see where things stand and hold each other accountable.
And the budget.
Budget reliability is the domain of target value design. By aligning the design with the budget from day one, TVD dramatically reduces the chance of those nasty cost overruns popping up later. You need smaller contingencies because you've designed out a lot of the risk. And using 5D cost management capabilities in BIM gives you that real-time, transparent view of costs, allowing for proactive adjustments, not reactive panic. Everyone knows where the project stands financially. Then there's quality reliability. The CM's job of monitoring contractor compliance with the quality level expected becomes easier and more effective. Why? Because collaborative planning in BIM help identify potential quality issues or specification conflicts early. Defects are prevented before they happen, rather than just being caught or missed during inspections later. It builds quality in, and underpinning all of this is risk mitigation. Lean doesn't treat risk management as a separate activity you do once and file away. A structured risk management methodology is woven into the weekly planning, the look-ahead process, the design reviews. Risks are identified collaboratively, tracked openly, and mitigated proactively. This means fewer nasty surprises, a more stable project delivery, and a team that feels much more in control.
Okay, that covers efficiency and predictability. But what about the people? Construction has this reputation, sometimes deservedly, of being adversarial. Different companies, different contracts, everyone kind of looking out for themselves. Does Lean really change that dynamic? Does it actually improve the team culture?
It absolutely does. And arguably, this enhancing team culture aspect is one of the most profound and lasting benefits of Lean. It actively works to create a highly collaborative, trust-based, and genuinely engaged environment. Think about it. Lean promotes a space where effective leadership promotes project success, where the whole team can focus on delivering results using a common vision and working towards shared outcomes instead of just protecting their own silo. The last planner system is a perfect example. It empowers those last planners, gives them real ownership and accountability. They feel heard, respected, and invested in the overall project success, not just punching a clock.
So it breaks down those silos?
It really tries to. It emphasizes open communication and trust. The PMBOK guide talks about stakeholder engagement, not just as informing people, but as actively working collaboratively to elicit requirements, manage expectations, resolve issues, negotiate, prioritize, problem solve, and make decisions. It's baked into the process. You see this collaborative spirit even in critical areas like safety. Holding safety coordination meetings where the contractor openly reviews job hazard analyses with all the affected trades, ensuring everyone understands the risks and safety guidelines are communicated effectively. It becomes a shared responsibility built on open dialogue. Lean also fosters continuous learning and improvement. It explicitly recognizes that there's a learning curve in any production process, including construction. It creates a psychologically safe environment where teams feel comfortable identifying problems, analyzing why things went off plan without fear of blame, and collectively figuring out how to do it better next time. It's about implementing ongoing improvement, learning from mistakes and successes.
Less finger pointing, more problem solving.
Exactly, which leads to proactive problem solving. Instead of reacting defensively when something goes wrong, Lean encourages teams to make full use of BIM to address problems and facilitate solutions together. Use the data, use the model, use the collective brainpower of the team to find the best way forward proactively. It shifts the culture from blame to solutions.
Okay, let's try one more imagined voice, maybe a project manager reflecting on this cultural shift. Imagined project manager voice. Honestly, for the first half of my career, it felt like my main job was dealing with conflict. Constant change orders because of design busts found too late, endless claims and arguments between subs about delays or scope gaps. It was exhausting, constantly putting out fires, mediating disputes. It often felt like an us versus them environment, even within the project team itself. It wasn't why I got into this business. Imagine project manager voice. Since we really committed to lean practices, particularly implementing LPS rigorously, the whole atmosphere has changed. It's not perfect, nothing is, but the level of engagement and transparency is just different. People trust each other more. Those collaborative planning sessions, they haven't just improved the schedule, they've pretty much eliminated the constant bickering over who caused what delay. And using BIM for clash detection. We catch so many issues in the virtual world now, issues that would have become huge fights in the field. When problems do come up, the instinct now is to get the right people together and solve it, not just cover your own backside. Everyone feels more invested in the overall project success, not just their little piece. It feels much more like a genuine partnership. And you know what? People seem happier, less stressed. The results are better, sure, but the process of getting there is just fundamentally healthier. That's really compelling. Hearing how it transforms not just the metrics, but the actual human experience of building, that's powerful stuff. Success stories, voices from the field, imagined narratives. Okay, to really hammer home the practical impact of all this, let's hear a few more of those imagined voices from the field. Real scenarios based on actual experiences showing how lean played out. Let's start with a contractor focusing on technology and schedule. Imagine contractor 1, focus, 4D BIM, schedule reliability, JIT. We were working on this complex high-rise right in the middle of downtown. Logistics were just a nightmare tiny site, heavy traffic, coordinating deliveries was critical. So we went all in on 4D BIM. We didn't just have a 3D model. We dynamically linked our CPM schedule activities to the 3D objects. So we could literally run simulations, watch the entire building go up virtually, week by week. This let us see potential bottlenecks like crane time conflicts or areas getting too congested months before they'd actually happen. We use these simulations to fine-tune the sequence and, crucially, nail down our material deliveries. Our structural steel deliveries, the big curtain wall panels, they arrived just in time, often the day they were scheduled for install. This drastically cut down on-site storage, which we barely had space for anyway, and minimized handling and potential damage. The result? We avoided the kind of major delays that typically plague these complex urban projects. In fact, we finished 3 weeks ahead of schedule and slightly under budget. That 4D planning and GIT coordination enabled by reliable workflow was absolutely key, ahead of schedule on a complex high-rise. That's impressive. Okay, how about an owner focused on value and sustainability? Imagine owner one. Focus. TBD, LCC, sustainability cost reduction. As a university, we had a mandate to build a new science center that was not only state-of-the-art, but also a showcase of sustainability aiming for late platinum within a very fixed bond-funded budget. We knew the traditional design bid build route was risky. We'd likely end up compromising our green goals during value engineering. So we committed to target value design from the outset. We brought the architects, engineers, and our CMGC partner together in a big room environment right from conceptual design. We set the lead platinum goal and the budget as our guiding stars. Using detailed life cycle cost studies integrated with their 5D BIM model, we evaluated everything based on long-term value. For example, investing more upfront in a highly efficient geothermal system and a superior building envelope had a longer payback on paper, but the life cycle cost analysis clearly showed it would save millions in energy costs over the building's life, making it the better investment in helping us hit our sustainability targets. Because cost implications were transparent throughout design, driven by those 5D cost management capabilities, we made informed trade-offs collaboratively. We achieved a LEED Platinum, stayed within budget, and got a building that will perform better and cost less to operate for decades. TVD allowed us to design the value in from day one. Designing value in, not cutting cost out. Great phrase. Okay, one more perspective. Maybe a project manager focusing on the overall management and predictability. Imagine project manager. Focus. Overall project management, reduce conflicts, improve predictability. For years, my biggest headache was the sheer volume of paperwork managing problems, RFIs, change order requests, potential claims. It felt like I spent more time documenting disputes than actually managing the project forward. Since we embraced lean principles across our projects, especially LPS for planning and incorporating a structured risk management methodology into our weekly routines, that whole dynamic has shifted. We identify potential risks, design ambiguities, procurement lead times, site condition unknowns much earlier in our look-ahead planning. We track them openly. Proactive stakeholder engagement means we're talking constantly, resolving issues collaboratively before they fester into formal disputes. There are just fewer surprises. Don't get me wrong, problems still happen, it's construction. But our approach is now proactive, innovative, and nimble, like the PMBOK says. We focus on solutions, not blame. The result is far more predictable schedules and budgets, happier clients who feel like part of the team, and honestly, a much less stressful, more collaborative environment for everyone. It's just a smarter way to build. Those stories really paint a vivid picture. It's clear lean isn't just a theoretical concept, it's delivering real, tangible results on projects of all types. 6. Call to action. Embrace the lean mindset.
So after hearing all this, what does it really mean for you listening right now? Whether you're that construction manager on site, an owner planning your next big investment, a designer shaping the built environment, or anyone really involved in bringing projects to life. Why should you care about Lindy? Why is embracing these practices maybe not just an option anymore, but becoming a necessity in this industry?
Yeah, I think there are some really compelling reasons that boil down to fundamental benefits. First off, pretty obviously, cost efficiency and value creation. Lean gives teams the tools and the mindset to deliver projects within the owner's financial resources, not by cutting corners, but by systematically rooting out and eliminating waste in all its forms, wasted time, materials, effort. It's about optimizing every step to create value for stakeholders, delivering more of what truly matters, often for less overall cost. Second, and maybe just as important, is predictability and reduced risk. That relentless focus on creating reliable workflow, solving problems proactively, getting continuous feedback, it dramatically improves schedule reliability and budget reliability. You minimize those nasty surprises. By identifying and tackling risks early and often, you significantly diminish the potential risk consequences, bringing a level of control and predictability that's often missing in traditional construction. Third, and this really came through in the stories, is enhanced collaboration and innovation. Lean fundamentally requires and fosters an environment where stakeholder engagement is real, not just a buzzword. It breaks down silos and invites everyone, designers, builders, suppliers, owners, to contribute their best ideas to find better ways of working. This doesn't just solve immediate problems, it builds a culture of innovation, making organizations, as Peter Drucker put it, capable of organizing themselves for innovation. It unlocks that collective intelligence. And finally, it leads to improved quality and sustainability. by making quality management an integral part of the process from start to finish, and by enabling the smart design and efficient construction of high-performance green buildings. Lean helps deliver products that are simply better, more durable, healthier for occupants, lighter on the planet, and aligned with the growing demand for genuinely sustainable solutions.
Absolutely. And remember, the construction industry isn't standing still. It's constantly dealing with emerging technology, new approaches, and rapid market changes. Adopting lean isn't just about catching up. It provides the framework, the mindset, the tools to actually get ahead, to be truly proactive, innovative, and nimble in delivering project outcomes. It's about building resilience into your projects and your organization. It's fundamentally about being smarter, not just trying to be faster or cheaper in the old ways.
So, at the end of the day, it feels like it's not just about managing projects more efficiently. It's really about leading them towards a future that's more collaborative, more sustainable, more reliable, and ultimately more successful for everyone involved. It's a big shift, for sure, but one that seems to promise some pretty profound returns. Outro. Wow. What an incredible deep dive that was. We've journeyed all the way from the origins of lean in Toyota's manufacturing plants right through to its powerful impact on how we build today. We've unpacked the last planner system, target value design, and seen how they contribute to massive waste reduction, much better reliability, and a genuinely transformed team culture on construction projects.
Yeah, it's been fascinating. And as you, listening, reflect on all of this, maybe think about your own work, your next project. And we talked a lot about identifying and eliminating wasted time, materials, effort, confusion, rework, maybe even wasted talent. Here's a thought to leave you with. What's just one form of waste that you see regularly in your projects or your organization? Just pick one. And then could you challenge yourself, challenge your team to start thinking about how you could systematically reduce or eliminate it? That journey towards becoming a truly lean, mean building machine, it really does begin with that first intentional step. The first question, is there a better way to do this? It starts with fostering that mindset of continuous improvement.
A powerful challenge indeed. Start small, but start somewhere. Thank you so much for joining us on another deep dive. We really hope this has given you some valuable insights and maybe sparked some ideas. We encourage you to keep exploring ways to build smarter, more collaboratively, and more effectively. We'll see you next time.